everyone! This week we're going to finish up talking about Chapter 3. Our goal for today is going to be to distinguish two broad, big picture kinds of arguments. Deductive arguments and inductive arguments. So we're going to get a little bit more narrow. We've been talking so far about arguments in a very general sense, not really drawing a lot of distinctions between different kinds of arguments. Today we're going to get our first real distinction between two different sort of very broad categories of arguments, deductive arguments and inductive arguments. It's going to be very important that we sort of begin by figuring out what kind of argument we're looking at, because we're going to sort of hold these two different kinds of arguments to different kinds of standards, and so we're going to evaluate them very differently. So that'll be our goal for today, figuring out what's a deductive argument and what's an inductive argument. All right, let's get started. All right, so let's start by talking about what a deductive argument is. Deductive arguments are determined by what sort of the author intends. So an argument is sort of deductive if basically if the author or the person making the argument intends it for it to actually be a deductive argument. Same thing true is for inductive arguments. If the author intends for the argument to be an inductive argument, then it's inductive and we'll judge it by that way. You'll sometimes have to use the principle of charity to determine which is which, and we'll talk a little bit more about that as we sort of go. All right, so let's begin with these deductive arguments. Let's just define it first. We're going to define a deductive argument as any argument where the author intends for the conclusion of the argument to follow with necessity from the premises. Or, comes to the same thing, but let's just put it slightly differently. It's an argument where the author believes that if the premises of the argument really are true, then the conclusion of the argument must, with necessity, with certainty, also be true. There's no other option for the conclusion to be true. So using our examples from last class, the argument Kara is a cat, all cats are mammals, therefore Kara is a mammal, this would be an example of a deductive argument. Let's think it through for a second, right? Assume that these premises really are true. Assume that Kara really is a cat, and it's true that all cats are mammals. Well, all right, then there's no other choice. If those two things are true, indeed, Kara has to be a mammal. There's no other option. And we can show this, and indeed we will show this. We can use Venn diagrams, right? We can sort of show, as we've defined our terms, there's no other option left but for Kara to be a mammal. There are lots of different types of deductive arguments. It's not just one. This is an example of what's called a categorical syllogism. We'll look at some others of those. There are a whole bunch of others, too. And we'll look at a few other types of deductive arguments. In general, deductive arguments are a little bit less common, because it's pretty rare that people are really saying that some conclusion we can know with certainty or with necessity. It does indeed happen, though. In mathematical contexts, deductive arguments are very common. In philosophical contexts as well, especially in ethics, most ethical arguments, at least some point along the line, are going to involve some deductive step somewhere in there. And it's also really common in computer science contexts. I sort of said earlier in the semester that we sort of basically talk to computers using arguments. That's what a program basically is. Those arguments are almost always deductive arguments. So computer science is another arena where we'll tend to see a lot of deductive arguments. All right, shifting the discussion, let's now talk about inductive arguments. Inductive arguments are a little bit more common. And basically, inductive just sort of means not deductive in a certain sense, right? Any argument that's not a deductive argument is going to be an inductive one. There's an enormous range of different kinds of inductive arguments, and we're going to talk about many of them. Because they're more common, they're the ones you're more likely to see in the course of your normal life. So those are the ones we'll probably spend most of the semester talking about. All right, so let's define what we mean by an inductive argument. In an inductive argument, that's one where the author intends for the conclusion to follow not with certainty, but with a high degree of probability or a high degree of likelihood from the premises. And again, let's put it differently. These sort of mean the same thing. If the premises are true, there's a very good chance that the conclusion is true, but it's not assured. But nevertheless, the chance is good enough that it's rational for you to believe that the conclusion is true, even though there still remains some chance that it could be false. So let's look at an example of this kind of argument. Again, picking one we looked at from last time. I studied hard for the test. I did all the homework. I've done well in all the previous tests, so I'll probably do well in this test too. And note, frequently, indeed, the conclusion will even contain something like probably or something. That'll be a hint that you're looking at an inductive argument, but it doesn't have to. The conclusion could just say, I'll do well in this exam too. Okay, why is this an inductive argument? Well, the conclusion's not certain. Right? It's possible something could still go wrong, that all three of those premises could be true, and something still just goes horribly wrong. I mean, I've been teaching for a while. I've never really seen a case where a student has all three of those things true for, and that they've done poorly on an exam. But it could happen, right? Let's say I screw up and make the exam really unfair. That's possible. Let's say something even weirder happens. Let's say the student, gets into a car crash on the way to the exam. Right? Or even let's just say that the exam is really different than previous exams and the student didn't use good studying methods. It's possible that the student could still fail despite all three of those things, but it's pretty unlikely. If you had to guess how the student was going to do, I, at least based on my experience, would guess that if those three things are true, the student's very likely to do well in the exam. And so, like I said, these are far more common forms of argumentation. It's comparatively rare that we're dealing with certainty in life. Normally, we're dealing with instances more of sort of probability and likelihoods, and that's where we'll be talking about inductive arguments. Alright, so now that we've said a little bit about what we mean by a deductive and an inductive argument, let's now talk about what would make a deductive and an inductive argument good or bad, right? Because that's ultimately our goal in this class. We're not just talking about arguments sort of academically in a sense. We want to evaluate them. We want to figure out what arguments are good, reliable, trustworthy, likely to lead me to getting the answers right, and what arguments are bad, unreliable, untrustworthy, and likely to lead me to get wrong conclusions about things. So let's start with the deductive arguments. We're going to call a good deductive argument a sound argument. That's just going to be a terminology. You do sort of just need to memorize this vocabulary. We need to sort of mean the same thing when we use some of these words. It's just, when we want to say that a deductive argument is good, that it's successful, we're going to say that the argument is sound. When we say that a deductive argument is unsuccessful, we're going to say that it's unsound. Right? So those are going to be our sort of two terms to designate good versus bad deductive arguments. Deductive argument is good if it satisfies two conditions. So there's sort of two things it's got to successfully do in order to count as a sound deductive argument. Condition one, the premises actually have to be true. Right? Our claim is that with a deductive argument, if the premises are true, then the conclusion has to be true. Well, okay, if the argument's going to work, we need to actually then really do have good premises. So that's our first condition. Our second condition, this is one we're going to spend more time in this class talking about. The arguer has to actually be correct in their assertion. It really has to be true that if the premises are true, the conclusion has to be true. The second condition we're going to call validity. An argument where this is true, where if the premises were true, the conclusion is true. We're going to call that a valid argument, whereas if it's in any sense possible that the premises could be true and the conclusion false, we're going to call this an invalid argument. When you're checking this second condition, this validity condition, the important thing really is to ignore the content of the argument altogether. It doesn't really matter specifically what the argument is about. It's going to be determined by the form that the argument has. So let's refer back to that example. Right? Any argument with the same form will indeed be a valid argument. For now, you can just take my word for it if you're not convinced. Any argument with this form will be a valid argument. So we could replace Kara with any other name. We could replace cat with any other species, and we could replace mammal with any other property. If we wanted to, we'd end up with a valid argument. Right? So long as the argument had this form, it would be valid. But if the premises are false, it still wouldn't be enough for it to be sound. So all arguments that are sound are valid, but not all valid arguments are sound. You can have a valid argument and it's still unsound if it doesn't have true premises. Alright, so now we've talked about what makes a good deductive argument. Now let's go look what makes a good inductive argument. We still have sort of two loose conditions, but it's a little bit looser. I mean, something being likely to true is a weaker condition than something necessarily being true. So these conditions are going to be a little bit weaker. So first of all, we're going to call a good inductive argument a strong inductive argument. And what we mean by strong in this case is that there's a greater than 50% chance that the conclusion is true. So if there's a 51% chance, the argument is strong. Now, if there's a 75% chance, though, the argument is stronger, right? It's more likely to be true. Strength is going to be sort of a relative notion, right? And again, if the argument was a 98% likely to have a true conclusion, then that's stronger still. That's really strong, right? So when we're talking about strength and weakness in inductive arguments, we're talking about this sort of relative, right? In absolute terms, anything greater than 50% is indeed strong. but it's stronger the higher that percentage gets, and it's weaker the lower that percentage gets. So strength and weakness is going to be our terms for talking about good inductive arguments. Again, just sort of memorize that. Make sure you don't talk about inductive arguments as being valid or invalid, sound, unsound. Those just aren't the right terms to use to describe this kind of argument. All right, so what actually makes a strong inductive argument? Well, the premises actually indeed still have to be true, or at least there has to be a very good chance that they're true. And again, that's sort of enough in this case, right? Because we're still dealing with probabilities. If there's a good chance that the premises are true, that might well be enough to make the conclusion likely. The other thing that has to be true is you sort of have to evaluate how likely really is it, then if the premises are true, that the conclusion would still turn out to be true. And again, anything greater than 50%, we're going to call that a strong inductive argument. So let's again go back to our example, look at that real fast, right? If it is really the case, I've never seen a student who satisfies all three of those premises and hasn't done well in the exam, so it's probably a pretty high percentage, right? Maybe 95% of the time when all three of those things are true, I've seen students do well. Not certain, but quite likely. And so the rational thing to believe is that the student who satisfies all those conditions will indeed do well. Think about it like this, right? So people sometimes get freaked out by inductive arguments and sort of say like, well, but couldn't the conclusion still be wrong? Sure. But the question is more like, if you gotta believe something, what's the more rational thing to believe? I mean, let's say there's a 95% chance that the student's gonna do well in the exam. It makes way more sense just to believe that the student's going to do well than that the student's not going to do well. I mean, the student could still not do well, but there's a very low chance of it. If you had to guess, you'd guess they'd do well. And this is even true if there's a 51% chance that the student was going to do well. I mean, could well happen that the student does poorly, but even if you had to guess, why would you guess for the thing with the lower probability? Your guess would be sort of better if you guessed the thing with the higher probability, right? So here's another way you could sort of think about a good inductive argument. A good inductive argument is one where what you should guess is what the conclusion says is going to be true. That's what you should actually guess will turn out to be the case. All right, one last little note before we call it for today. Let's just talk about how diagramming arguments relates to this inductive and deductive stuff. All of deductive arguments are going to be instances of linked support. And the reason for that is that, again, it's a very high standard, right? For a deductive argument, the conclusion has to be certain to be true. What it is that's going to make the conclusion certain is the way in which the premises work together. Individually on their own, no premise is going to be enough to sort of ensure certainty. I guess unless it's like a one premise deductive argument. If there's more than one premise, it will always be joint support or linked support. The premises will always be working together to establish that the conclusion is certain. That's not true with an inductive argument. Inductive arguments can use any kind of support, or even a mixture of different kinds of support within it. So it's harder to tell necessarily what you're looking at with an inductive, but anything you're confident is a deductive argument, you can also be confident that you're looking at an instance of linked support. All right, that's going to do it for this video. So just focus on getting these concepts down pretty well. I'm going to give you your quiz, be asking you to sort of make sure you understand what's going on with deductive and inductive stuff. In class, we'll talk a little bit more about diagramming, maybe practice a little bit more. Also do some problems where we sort of work on telling the difference between whether or not an argument is deductive or inductive. There will be an exam on Chapter 3 after the end of this sort of unit of the course. So study up for that. All right, that's it for today. So I will see you later. Bye.